Okay, so we're starting 16.1 notes, volume of prisms and cylinders. So we're going to go in a two-part video for this. The first part will be over prisms. So the first things we're looking at is just a little bit of vocab. Right prism, that's just telling you that your angles from your side, or this is what's called your lateral edges, and your base are going to be 90 degrees. And then you've got your right triangle where your height and your base are actually going to make a 90-degree angle. So keep that in mind when you're thinking of how to solve things. Go through, we're going to mark off that investigation and look down here at the bottom. You've got your two formulas that you're going to need because we're going to be looking at volume. Okay, so remember, volume is the amount of space inside of a 3D figure. In this case, we've got volume equals length times width times height for a box or a prism, and then we've got volume equals side cubed for a cube. And that's just because your length, your width, and your height, they're all going to be the same number. Okay, looking at this first one, we've got a real world problem of a aquarium. Okay, they've given it to us and they want us to find the volume of it and then convert it into gallons. So you're going to see this a lot. We're going to do our length times our width times our height to find our volume. Okay, so that's in feet squared. Well, they don't want it in feet squared. They want it in gallons. So we're going to do a conversion, just like chemistry class. Feet on top, feet on bottom, and our conversion factor. You multiply across the top and divide by the bottom to get your gallons. Okay, they also wanted to know how much the weight was, so they give us another conversion factor. Okay, remember, gallons on top, gallons on bottom. Multiply across the top, divide by the bottom, and that gives you how many pounds. Looking down here at the bottom, we've got ice. Okay, we're looking at volume and density. So when you look at this one, it says find the volume of the cube. We want to do length times width times height. A cube, they're all the same. So 3 times 3 times 3. That's where we get our 3 cubed equals 27. Then we want to use our density and our conversion to go through. So when we convert volume to mass, we're going to use this conversion. Okay, so we take our 0.9167 and we're going to multiply that by our 27 centimeters cubed to get 24.8. Then we're going to use the other conversion factor, which is just 1 to 1, and convert it into centimeters squared. So there is your first set of everything for that. Okay, turning to the next page. Okay, these are just a couple of examples. So this one, we're wanting to find the volume of the figure. They've given us how much the volume of 1 cube is. So we're just going to take that and multiply by the number of cubes. There's 11 cubes. So 8 times 11 gives us our 88 units cubed. Okay, cubic units. Then we're going to look at finding the area of the base of a pool. So first, they've given us our volume, okay, and they've given us our height. Now, they did not give us the area of the bottom, okay, and they also gave us our volume in gallons. So we're going to have to convert it to feet first because we want it in feet. So we do our gallons on top, put our conversion factor, feet on top, gallons on bottom, multiply across the top, divide by 1, and that's our 6,700 feet cubed. Now we have our volume in feet. So we're going to put that into our volume formula, which is just length times width times height, or our area of our base times our height. And that's going to equal my 6,700. Okay. 10 is our height that they gave us. We divide by 10, and that's going to be our area of our base. Okay, now looking into the next part, we're going into the volume of cylinders and different types of cylinders. Okay, and we're also looking at oblique prisms. So oblique just means that it is going to be slanted to the side, so your height's actually going to be on the outside. Same with an oblique cylinder. You've just got your height on the outside. Nothing else is going to change, just that they're going to be tilted. And that's where this comes into hand. Cavalari's principle. Okay, Cavalari's principle just means that your cross section and your height are the same. They're going to have the same volume. So whether my height is on the outside or on the inside, they're going to have the same volume. So an oblique prism with the same size base and a right prism with the same size base are going to have the same volume.